And now I'd like to show a little bit more about the display options that we have in the horizontal menu. Remember, we just finished off with the roll mode, and now I'd like to show the X versus Y mode. In order to do that, what I have is a function generator. I have two signals coming in. These are 100 kilohertz sine waves, and I have them in phase, as you can see. One way, if you're analyzing waveforms that are similar, you can take a look, and sometimes you want to know the phase differential. In this case, we have 0. We could do 180 degrees out of phase. And you can see now we're 180 degrees out. And you can take a look at the display with respect to time, let's say X versus time or amplitude versus time, and you can get a lot of data out of that, or a lot of information. But another way classically to represent this is with a Lissajous curve, which is the X versus Y. And so we go to menu in the horizontal and we change the time base to X versus Y. And now you'll see that we have a line that's been drawn. The reason that we have a line is, and again, this is channel 1 versus channel 2 being plotted. Again, these are 180 degrees out of phase. If we set them to 0 degrees out of phase, you'll see that it flips the line. If we set them to 90 degrees out of phase, that will become a circle, and we may need to adjust the sample rate. Again, the horizontal is going to adjust our sample rate. We have 500 megasamples per second, so we can actually change that. And also, we can change the location. And I guess we can center it up a little bit. Channel 2. Remember, channel 1 is going to be one axis, channel 2 is the other axis. So we can center that up a little bit. And now what we have is that we have a perfect circle because these are 90 degrees out of phase. So we're plotting X versus Y, and now we get the phase is going to be a circle when they're 90 degrees out of phase. If we did something like 125 degrees out of phase, you'll see that will turn into an ellipse. So that can be very useful when you have when you want to see the phase differential between two incoming signals. Again, that's the X versus Y mode, and we also can enable a second axis if you want to do channels 3 versus channel 4, which can be helpful if you're analyzing some more signals that way. An easier way of measuring the phase differential, though, is actually to go back to, because we have such a strong digital engine, we can go back to the Y versus T mode. Whoops, overshot it. I'm just going to adjust these a little bit so we can see. So now this is a little bit more difficult in order to find out what the phase differential is, but again, we have quite a bit of power here with our scope, and we can open up the horizontal menu over on the left-hand side, and we have a down arrow, so we can open up the second menu, and you'll notice that we have delay, channel 1 to channel 2, rising edge, delay, falling edge, phase rising edge, channel 1 to channel 2, and phase differential of, I guess, falling edge here. So let's just rising edge, and now we have 125 degrees, which is exactly what we have with our function generator. Now I'm going to put in 11 degrees. You'll see now we're making an automated phase measurement here. Let's do 186 degrees, and so we come up with, oh, I'm sorry, my function generator got angry. How about 145 degrees? So now we're at 145 degrees. So you can also use the automated measurement capability of the instrument, of the DS6000, in order to make those phase measurements between channels, which can be extremely useful as well. And quite a bit faster, I think, but the Lissajous curves, or the X versus Y mode, can also be helpful. And now I'd like to take a closer look at some other, one more feature actually, the display persistence on the DS6000 before we wrap this up. I'm going to disable channel 2. And I'm going to get rid of this measurement in order to make the display a little bit more clear. And we'll just hit all items. And now what I'd like to do is, I have a 100 kilohertz sine wave. I'm going to modulate that. And I'm going to modulate that at, let's say, what's my frequency here? I'm going to modulate that at 10 hertz. And I'm going to bring it down a little bit and enlarge it just a touch. And so now you can see that we do have modulation, but it's fairly tough to see what the maximum values are, or what type of changes we have going on here. What you can do with the scope is, with the display button, we can turn the minimum persistence. Persistence is just going to change the amount of time that each of the pixels is going to be lit. If we go to infinite, we can see our update, which is the darker line, and then we also see in the back we have this shadow, or a little bit less bright line, and that's going to be overwriting the pixel. So every time the waveform has overwritten in that area, it's made that pixel a yellow color for channel 1, and it's going to stay that way as long as we don't move any of the waveforms. As soon as we move the waveform, it's going to automatically overwrite everything, clear it, the display, and then start back over again. But what you can do with this is build up a almost like a peak hold. If you had a signal that was repetitious and supposed to be the same shape all the time, if you wanted to look for a glitch, you could set the persistence and then look to see if there were any lines outside of that standard waveform pattern. So again, if you're looking for glitches or any kind of problems that are intermittent in nature, just changing the display persistence can be extremely helpful in that regard. That basically goes over most of the DS6000 features. If you have any questions, please feel free to call us here at Rigol. It's 440-232-4488. We have applications engineers on staff, and we'd be ready to take your call. Thanks again for watching, and if you have any questions, please drop us a line. Take care.